Welcome to my new lecture, Estimate Activity Duration. Estimate activity duration process is part of project time management where project manager work on to estimate duration for each activity related to the project work. This process starts right after the sequence activity process where you draw a network diagram. As a project manager, it's your primary duty to prevent your team members from padding. So, what is padding? Always remember, you must involve your team member in this process. If you ask a question from your team member to give the estimate for an activity, he or she should or must give you complete justification for duration for that specific activity. Otherwise, that team member will just guess the duration, which will later on in the project may disturb the deadlines. So, what is padding? In padding, a team members, for instance, he has no idea how long this activity will take, so he will just say, I will take my best guess and just double it. For instance, an activity will take 3 days to complete, he will likely say it will complete or will be completed in 6 days. So, how estimating is done? You must provide the team with enough information to properly estimate each activity. Let those doing the estimating know how refined their estimates must be. You must complete a sanity check for the estimates. You must prevent padding, formulate a reserve, and make sure assumptions made during estimating are recorded for later review. So, estimate activity duration. Once the activities are defined and sequenced and type and quantity of resources required for each activity are identified, the next step is to estimate how much time each activity will take. Estimate activity duration is the process of approximating the number of work periods needed to complete individual activities with estimated resources. Since each and every process in project management is divided into 3 parts, that is inputs, tools and techniques, and outputs. So right now you are at this stage to estimate duration for your different activities of a network diagram. So you need a schedule management plan, you need project management plan. In project management plan, we have specified that we are going to use these tools and techniques and processes for project time management. So you need project management plan as an input to estimate activity duration. You need schedule management plan which contains scheduling tools, methodologies, reporting formats, activity identification, sequencing, estimating resources, and different things. You also need a scope statement. What is a scope statement? A scope statement is a comprehensive document which contains what is included in the project and what is excluded from the project. Next thing is a work breakdown structure. Work breakdown structure is a graphical representation of your project from top to down. And you need work breakdown structure dictionary as well, where you explain your work packages in detail. You also need activity list, which is the output of define activities process, which we have learned so far. You need activity attributes list. Activity attributes list contain activity name, description, its logical relationship of different activities with predecessors, lead and lag, successors, and relationship column. It also contains number of and type of resources required, skills requirement, and other documents. And you need milestone list as well. It is a significant point to achieve something in your project. You need project team assignment. This document contains project team members mentioned in the front of each activity of the project. For this purpose, we just update activity attributes document. For instance, you can see here number and type of resource required, skills requirement, and other required resources. So you will take this document activity attributes and you will specify or update your documents and fill these columns only. You need resource calendar, requirements and risk register. You need resource calendar which contains the availability of resources data, whereas in resource requirement explains the skills needed for the activity to complete well on time. For example, if additional or power skills resources are assigned to an activity, there may be reduced efficiency or productivity due to increased communication, training and coordination needs, leading to a longer duration estimate. In project risk may impact resource selection and availability. So these are all inputs you need to work on estimate activity duration. You need project management plan, you need schedule management plan, you need work breakdown structure, you need work breakdown structure dictionary, you need project scope statement, define activities, sequence activities means network diagram, you need activity attributes document, you need milestones list, you need resource requirements, you need calendars, you need risk register. It means you need everything. Whatever you have done so far becomes input to this process. This process is core to project planning. So let's talk about the tools and techniques of estimate activity duration. First tool and technique is one-point estimating. It can force people time using a one-point estimate. The estimator submits one estimate per activity. For instance, you ask your team members that I'm going to assign activity A and B to you. How long it will take? So as a team member, this is your duty. You must provide proper estimate for your activity. For instance, you say I will take 3 days to complete for activity A, and activity B I will complete in 6 days. So in one-point estimating, you did not estimate the pessimistic approach or risk, or you did not calculate optimistic approach. So in one-point estimating, it can force people time using a one-point estimate. The estimator submits one estimate per activity. So let's talk about its negative effects. It forces people into padding their estimates. Obviously, if you are not calculating the pessimistic approach, if you are not calculating the optimistic approach, so obviously it means that perhaps you are just guessing your idea how long this activity will take. It hides important information about risk and uncertainties from the project manager. When a person estimates that an activity will take 20 days to complete and it is completed in 15 days or 14 days, whatever, it can make the person who provided the estimate look untruthful and untrustworthy. It often results in the estimator working against the project manager to protect themselves. But it doesn't mean one-point estimating is prohibited in planning of the project management or your project. It is used, but it has some negative effects as well. So let's talk about analogous estimating. Analogous estimating can be done for a project. For instance, your sponsor asks you to give the estimates as quickly as possible. So obviously at this stage you cannot perform detailed work. So analogous estimating can be done for a project. What will you do? You will take similar previous projects and you will just make some changes according to your project, and then you will provide your estimating work to your project sponsors. So analogous estimating can be done for a project. The last 5 projects similar to this one each took 8 months, so this one should also or an activity The last two times this activity was completed, each took 3 days. Since we have no other information to go on, we will use 3 days as estimate for this activity and the remaining estimate when more details becomes available. In parametric estimating, you just multiplies the quantity of work by rate. For instance, you are working on a company-wide network upgrade project. This requires you to run a new cable to switches on every floor in the building. You can use parametric estimating to determine activity duration estimates by taking a known element, in this case the amount of the cable needed, and multiplying it by the amount of time it takes to install a unit of cables to come up with an estimate. In other words, suppose you have 10,000 meters of new cable to run. You know from past experience it takes 1 hour to install 100 meters. Using this measurement, you can determine an estimate for this activity of 100 hours to run new cable. Therefore, the cable activity duration estimate is 100 hours. In parametric estimating, it identifying an item to be estimated, estimate the number of items, estimate in effort per item, multiply effort per item by number of items to determine the total effort. We have talked about 1-point estimating. Let's talk about 3-point estimating. As we know, things do not always go according to plan. Therefore, it is often best to estimate estimates in a range using 3-point estimates. Analyzing what could go right and what could go wrong can help estimators determine an expected rate for each activity. We have triangle distributions, we have beta distribution. In triangle distribution, you just find pessimistic value or pessimistic duration, most likely duration, and optimistic duration. You just add pessimistic, optimistic, and most likely, and you just simply divide it by 3. This is called triangle distribution, where you are not sure in most likely cases that how long this activity will take. You just specify that this activity will take, for instance, 4 days to complete, but you are not 100% sure. Then use this triangle distribution. Whereas in beta distribution, it is the same, but it multiplies with 4 and divide by 6. This beta distribution method will be adopted when you are very confident on most likely value. For instance, you have activity A, B, C, and D. You have estimated that for activity A, in pessimistic approach, it will take 47 days to complete, whereas in most likely case, it will be completed in 27 days. And if in very good scenario, this activity will take 14 days to complete. So what will you do? You will add 47, you will add 27 and 14. 47, 27 and 14. When you will add these 3 values, it will become 88. So you will just simply divide 88 by 3 and the result is 29.33, like here. Similarly, here you can see most likely value was 27, but after applying this formula, triangle distribution, the result is 29.33. Similarly, 89 plus 60 plus 41 equals to 190. Just divide by 3 and the result is 63.33. Here you can add 48, then 44, then 39, which is 131, divided by 3 and the result is 43.66. Here you have 42 plus 37 plus 29, that becomes 108, divided by 3 and the result is 36. So this is how we calculate triangle distribution by using this formula. So you can see the difference between normal most likely value and triangle distribution. Here the result is 27, 29, 60, 63, 44, 43 and 37. Here it is 36. Since we have calculated the triangle distribution values, now let's talk about beta distribution. In beta distribution, what we do, we just add optimistic values, pessimistic values, but we multiply most likely values with 4. This shows our confidence level on most likely values, and we do not divide by 3 but we divide by 6. The use of beta distribution gives stronger consideration to the most likely estimate derived from the program evaluation and review technique. This technique uses a formula to create a weighted average for work to be done, that is pessimistic plus 4 into most likely plus optimistic and divide by 6. So it's your work, it's your assignment that you find expected activity duration based on beta distribution here in this column. Similarly, you can find beta activity standard deviation by using formula pessimistic minus optimistic divided by 6. Like here in this example, you can see beta activity standard deviation pessimistic minus optimistic divided by 6. And then finally we find the ranges for our estimates. Note that the formula we have been discussing relate to activities rather than the overall project. You can also use this information to calculate the overall project estimate and the project standard deviation to help manage a project successfully. Consider how these ranges might affect the estimate of the overall project duration and cost, and use this knowledge to effectively address variations on your project. Like here we have the results. In this column, based on the formula pessimistic plus 4 into most likely plus optimistic divided by 6, we have 28.16, 61.667, 43.833 and 36.500. Whereas in beta activity duration, the formula was pessimistic minus optimistic divided by 6. So the result is pessimistic is 47, optimistic is 14, and then you will divide the value by 6. So here is the answer: 5.500, 8.000, 1.500, 2.167. So you cannot say here directly that this activity will take 28.167 days to complete, but you can say by adding and subtracting 5.500 with this value that 22.667 to 33.667 this activity will take or can be completed between 22 days to 33 days. So why do project manager needs to understand expected duration, range estimates and standard deviations? The main purpose is to use these concepts to better monitor and control projects. These calculations help you know the potential variances on your project and determine appropriate course of actions. You can use estimate ranges and standard deviation to assess risk. Looking at the table presenting beta standard deviation in this section, which activity has most risk? The answer is B. It has the widest range and the highest standard deviation and is therefore likely to have the greatest risk. These calculations are based on pessimistic, optimistic and most likely estimates for an activity. Another tool and technique is called data analysis. Alternative analysis are used to compare various levels of resource capability or skills, and reserve analysis is used to determine the amount of contingency and manage reserves needed for the project. For example, comparing options such as outsourcing work versus completing it internally to meet a schedule constraint, or purchase testing software to decrease the time of manually testing components. Alternative analysis involves evaluating the impact of each option on project constraints, including financial investment versus time saved and level of risk. We have decision making. Decision making technique can be used in this process include voting. In this technique, project manager asks team members to show their level of support for decision by holding up a closed fist, 1 to 5 fingers. If a team members hold up fewer than 3 fingers, the team members is given the opportunity to discuss any objections with the team. The project manager continues the fist of 5 process until the team achieves consensus. Everyone holds up 3 or more fingers or agrees to move on to the next decision. Next tool and technique is meetings. Meetings and expert judgments are the common tool and techniques which we use in all processes almost in project management. Do not forget, click the subscribe button, hit the bell icon. Thank you.